Hello friends, welcome to Learner's Planet. Friends, this is our first session for rational numbers. In this session, we are going to discuss some different type of numbers like natural numbers, integers, whole numbers. Then we'll be discussing about rational numbers in detail. Okay, you might have studied about various types of numbers in your junior classes, but we'll be having a quick recap of all the types of numbers. So let's begin this session. First of all, let's discuss about natural numbers. What are natural numbers? The counting numbers, right? What we say, like if we wish to count anything like 1 tree, 2 boys, 3 persons, 4 pencils, 5 pens, 6 books, right? So the numbers which are used in counting, we call them as natural numbers, right? So natural numbers is denoted by n, right? And we also call them as positive integers. This I or Z, this is the sign of integers, and I plus or Z plus, that means positive, right? So natural numbers are also called positive integers. Okay. So n is how we represent natural numbers as capital N. So it is a set of counting numbers, that's 1, 2, 3, 4 till infinity. Okay. Now we have whole numbers. Now we have discussed about natural numbers. In natural numbers, 0 is not there. But in case of whole numbers, one more element, 0 is there. So that means whole number has, the set of whole number has one more element than natural numbers, right? In natural numbers, we saw that the counting starts from 1, 2 and it goes till infinity. In case of whole numbers, the set starts from 0, right? 0 is also an element of whole numbers, right? So natural numbers including 0 are called whole numbers. Okay, we denote whole numbers as W, right? And this is what non-negative integers, because see, there are three types of integers, that's positive integer, negative integer and 0, right? So non-negative integer, that means 0 as well as positive integers, right? So these are the whole numbers, they start with 0, right? And we can say natural number is subset of whole numbers, right? All the elements in natural numbers are already there in the set of whole numbers. So natural number is subset of whole numbers. Okay. Similarly, let's discuss about integers. Now integers are what? See, we have natural numbers, we have whole numbers. Now you see integers, see negatives and positives as well as 0, right? So the negative whole numbers, or we can say negatives of natural numbers as well as 0 and natural numbers themselves, all of them are making the set of integers, right? We call it as I or Z, right? So these are negatives of natural number, these are natural number themselves, and this is 0. So negative, 0 as well as positive numbers. So precisely integers is like whole numbers as well as negatives, okay? But in fact, in the case of negatives, they should be whole numbers, right? So precisely they are negatives of whole numbers. Now, if we wish to present the set of negative integers, that means it's like -3, -2, -1, like from minus infinity, right? Similarly, set of non-positive integer is what? 0 will be included. Okay, and 0 is neither negative nor positive integer. So we got negative integer, that means from, right? Then if we call non-positive, in that case 0 will also be included, right? If we wish to get the set of positive numbers, positive integers, that means the set will start from 1. Okay, in that case 0 will not be included because 0 is neither negative nor positive integer. Okay, so I hope you are clear with the definitions of natural numbers, whole numbers and integers. Among these three, integers is the set of integers is the biggest because whole numbers as well as natural numbers, both of them are part of integers. Okay, so the set of integers is the biggest among these three. Yeah. Now let's discuss about rational numbers. All the numbers which can be represented in the form p by q, where p and q are integers and q is not equal to 0, are called rational numbers, and the set is denoted by q, right? So the numbers should be represented in the form of p by q, and p and q should be integers. Right, here I can take some examples, maybe 3 by 2, maybe minus 2 by 3, maybe minus 5, 4, 6, all of them, right? All of these are rational numbers. Why? Because here 3 is integer, 2 is integer. Here minus 2 is integer, 3 is integer. Here minus 5 is integer and 1 is integer. Here 4 is integer, 1 is also integer, 6 and 1, right? So all of them are rational numbers. So precisely the rational numbers can be represented in p by q form, where p and q, both of them are integers, may be positive, may be negative, and denominator should not be equal to 0. That is the very important condition. Okay, the denominator should not be equal to 0. Okay, so this is what rational number is. So natural numbers, whole numbers, integers, all of them are part of rational numbers, because rational numbers may be negative, may be positive, may be fractions, right? As we can see over here, this is a fraction, this is a fraction. Okay, so a rational number is the biggest set among these four. Okay, so what we can say, natural number is subset of rational number, whole number is subset of rational numbers, integers is subset of rational numbers. Okay, so if multiple choice questions, these sort of like concepts may be asked, so you should be clear that natural number is also subset of rational numbers, whole numbers as well as integers, all of them are subset of rational numbers, and natural number is subset of whole numbers, and natural number is subset of integers, whole number is subset of integers, and all of them are subset of rational numbers, right? So the smallest set is natural number, then after that it's whole number, then integer, then rational numbers. Okay, so I hope you are clear. Now friends, let's take some examples and try to find out that which type of rational numbers are the these numbers. Suppose I have 2 by 3, right? It's a positive rational number. Right? If it is minus 2 by 3, it's negative rational number. Okay, if it is maybe minus 4 by minus 5, in that case this minus sign will be cancelled, so it's a positive rational number. Okay, the next thing, let's discuss about simplest form of rational numbers, or we can say lowest form. Now suppose we have a rational number, say 4 by 5, right? And we have the rational number as maybe 36 by 45, right? Now both of them are same. Now how could I say that? Because see, 36 can be factorized as 9 into 4 and 45 can be factorized as 9 into 5, right? So in that case 9 is a common factor, so from numerator and denominator it can be cancelled. So further we are getting 4 by 5. That means 36 by 45 is nothing but 4 by 5, right? So the simplest form of 36 by 45 is 4 by 5 when the HCF of numerator and denominator is 1, right? How do we get the simplest form? HCF of numerator and denominator is 1, right? So if HCF of numerator and denominator is 1, that will be the simplest form of a rational number. I take more examples. Suppose I have 15 by 20, right? Now 15 is what? 5 into 3, and this is what? 5 into 4. So it's 5 and 5 will be cancelled, so we'll be getting 3 by 4. So 3 by 4 is the simplest form of 15 by 20, right? Similarly, maybe 18 by 27. So it's 9 2s are 18, 9 3s are 27, right? So 2 by 3 is the simplest form of 18 by 27. We can see that HCF of 2 and 3 is 1. Okay. So similarly, we can calculate the simplest form of rational number, and maybe we can call it as lowest form as well. Now from this we can say that two rational numbers are equal if their simplest form are equal, right? That means what? That means 36 by 45 is actually equal to 4 by 5, right? So two rational numbers are equal if their simplest form are equal, right? So 36 by 45 is 4 by 5, or we can say maybe 20 by 25. So it's 5 4s are 5 5s are, right? That means 36 by 45 is equal to 4 by 5, and 20 by 25 is also equal to 4 by 5. That means 36 by 45 is equal to 20 by 25, right? Precisely all of them are 4 by 5. Right? So that these three rational numbers are equal, right? Similarly, we can establish a funda over here, that is equality rational numbers. Now suppose I have maybe 20 by 25, right? And the other is 4 by 5. Okay. Now I have to check whether these two rational numbers are equal or not. So what I can do is, we can go for cross multiplication. So 20 into 5, and here 25 into 4, right? So it's what? 100, and it is also 100. That means we are getting product as same in both the cases. That means these two rational numbers are equal, right? So this is how we can prove the equality of rational numbers. Okay. And similarly, I would like to share one tip over here. If this is greater, if this product is greater, that means this fraction will be greater, and if this product is greater, that means this fraction will be greater, right? For example, 4 by 5 and 7 by 8, right? So it's 4 into 8, and it is 7 into 5. So it's 32, it's 35, right? So this is greater, that means 7 by 8 is greater than 4 by 5. Okay. So that's an important technique, and which is like commonly used in case of even your examination. You can use this technique if you wish to compare between two rational numbers or two fractions. Okay. So just go for the cross multiplication. Doesn't matter you write 7 by 8 this side or this side. Maybe you wish to write it this side, then also it doesn't matter. This product you have to write this side, and this product you have to write this side. So 35 is greater than 32, that means 7 by 8 is greater than 4 by 5, right? So this is the cross multiplication method to check the equality, or maybe greater than or less than among the rational numbers. Okay. Now friends, let's learn to add the rational numbers. I take a very simple example. Suppose I have 2 by 3 and maybe 4 by 3. Now both of them are rational numbers. First just look at the denominator. In this case the denominator is same. So what you do? This is the second step, right? Okay, just take the denominator over here. Then add the numerator as it is. Okay, so 2 plus 4, 6 by 3. So 6 by 3 is what? 2. Okay, so this is how we can add the rational numbers. Now you should be clear and you should be careful about the sign of the numbers, right? Suppose I can take this first example. Here the denominator is same, right? So we can take the denominator as it is. Then this is minus 5. Just copy it as it is, and this is 3. If no sign is there, that means we have to assume that to be positive. Now minus 5 plus 3 is what? Minus 2, and this is 7. So addition of these two is minus 2 by 7. Okay. Similarly, we can take this to, it's minus 15 by 4 and 7 by 4. 4 as it is, it's minus 15 plus 7. So minus 15 plus 7 will be minus 8 by 4. 8 by 4 is what? 2. So it's minus 2. Okay. Similarly, here it's minus 8 by 11. I take 11 as common. It's minus 8 and it is minus 4. So minus 8 and minus 4 will be minus 12, and this is 11. Okay. Similarly, I take this. (13) common. This is 6 and this is minus 9. So 6 minus 9 is what? Minus 3, and this is 13. So addition of these two is minus 3 by 13. So everywhere you might have observed that we have to be careful about the sign of the number, right? Here the 15 is having minus and 7 is plus. Here minus minus 8 and it is minus 4, and here in this case 6 is positive and 9 is negative, right? So if we are adding them, you just have to retain the sign. That means the sign of the numbers will be as it is. Okay. So these are the examples when the denominator is same of both the rational numbers. And if you have more than 2 rational numbers, then also the method is similar. Okay, that will be taking later on. Now friends, let's take the cases when the denominator of rational numbers are different, right? Here it is 4 and here it is 8. So what is the first step? You have to find out the LCM of denominators, right? So LCM of 4 and 8. And how do we find that? That you have learnt in your junior classes. So LCM of 4 and 8 will be 8. Okay. Now what you do? The next step, take the first number 3 by 4. Now how do we get 8? If we multiply the denominator by 2, so you multiply the denominator by 2 as well as numerator by 2, right? So from the same number, if we multiply the numerator and denominator, then the effect is cancelled, right? So and 3 into 2 is 6 and 4 into 2 is 8. Now 3 by 4 and 6 by 8, they are like same fractions, right? Same rational numbers, right? We can see this 3 by 4 and 6 by 8. This is also 24 and this is also 24. That is 6 into 4 and here it is 8 into 3. So they are equivalent, or we can say equal fractions or rational numbers, right? So 3 by 4 can be written as 6 by 8. Okay. Now we are having one number as 6 by 8 and other as minus 5 by 8. Now we have the common denominator. Take it as common and the remaining operations are same as in the previous case. So it's 1 by 8. So addition of these two rational numbers is 1 by 8. So what is the first step? Find out the LCM of the denominators, then convert this of the fraction into both the fractions into common denominators, right? Then add as we did in the previous case. Okay, I'll take more examples. Now let's take this example. Here there is negative sign in the denominator. So friends, it doesn't really matter that the negative is in denominator or it is in numerator, right? So 5 by minus 9 or minus 5 by 9, both of them are same, right? So it's minus 5 by 9 and 7 by 3. Now the denominators are not same, so we have to find out the LCM of 3 and 9. So LCM of 3 and 9 is 9. Okay. So Now minus 5 by 9 is as it is, but 7 by 3, what we do? To which number we multiply the denominator, so we will be getting 9, that's 3. So multiply numerator and denominator by 3, right? So 7 into 3, 21, and 3 into 3 is 9. So 7 by 3 and 21 by 9, both of them are same, okay? Because we have multiplied the numerator and the denominator, both of them with a common number, with the same number. That's 3 over here, right? So 21 by 9 and 7 by 3, both of them are same. Now I have to add minus 5 by 9 and 21 by 9. Now both of them are having the same denominator, so just take the denominator as common. Now this is minus 5 and this is plus 21. So 21 minus 5 is 16 and this is by 9, right? So addition of these two fractions or these two rational numbers is 16 by 9. Okay, I hope you are getting. Now let's take this problem. Here it is minus 3 by 1 and 3 by 5, right? So denominator is what? 1 and 5. So first of all we have to find out the LCM of 1 and 5. That will be 5 only, right? I just write it over here. LCM of 1 and 5 is 5, right? So this can be written as into 5 by 5. So it's minus 15 by 5, right? Now this is minus 15 by 5 and other number is 3 by 5. Take 5 as common, then it is minus 15 plus 3, so it's minus 12 by 5, right? So once you made the denominator as same, then the calculation is very easy, right? You just have to add up the numerators, okay? The denominator will remain same, okay? So addition of minus 3 and 3 by 5 is minus 12 by 5, okay? Now we have these two numbers, minus 7 by 27 and 11 by 18. So first of all, we have to find out the LCM 27 and 18. Now, how do we find the LCM of 18 and 27? It's 18 is 3 into 3 into 2 and 27 is 3 into 3 into 3. Right? So LCM will be highest power of 3, that is 3 times 3 and then 2. So it's 54. Okay, that means LCM of 18 and 27 is 54. Now we have number minus 7 by 27. Now how do I get 54 in the denominator? If I multiply 27 by 2, right? So in the numerator and in the denominator I just multiply by 2. So it's minus 14 by 54. Similarly 11 by 18. If 18 is multiplied by 3, we will be getting 54. So numerator and denominator, both of them should be multiplied by 3. So it's 33 by 54. Now the denominator is same. We can add them as it is. So it's 54. So it's minus 14 plus 33. Okay. So it is 19 by 54. Okay. Now let's do this problem. We have to simplify this expression. Now first of all, we have to find out LCM of 9 and 6. So LCM of 6 and 9 is 18, right? Now to save time, what you can do, just write 18 like this. Now just see how many times in 9 you are getting 18. So it's 9 twos are, right? So what you got? 2. Now multiply the numerator by 2. So it's 16. Write it over here. Similarly, just retain the sign plus and minus. So you'll be getting minus over here. Now 6, how many times 18 you will be getting in 6? That's 3 times, right? So multiply the numerator by 3. Okay, so 11 into 3, 33. Now 16 minus 33 is minus 17 and this is 18. right? So simplification of this is like this, right? So instead of taking LCM separately and then taking them together, this will be rather shorter method. Okay. Now in this question, first of all, let's find out LCM of 16 and 24. 16 is equal to 2 into 2 into 2 into 2. 24 is equal to 2 into 2 into 2 into 3. So LCM will be 4 times 2, and 1 time 3, right? So it's 48. Okay. Now next step, write 48 as it is, and here we are having negative sign. Now just see how many times 16 in the, like in 48 16 is coming, that is 16 into 3, right? So you are getting 3. Multiply this 3 to the number over here, that's the numerator. So 3 into 5 15, and we are having negative sign over here, so it's minus 15, then plus. Now 24 into 2 is 48, right? So 2 into 7. Okay. Now minus 15 plus 14 is minus 1, and this is by 48. Okay. So addition of these two is minus 1 by 48. Okay. Now here it's 1 upon minus 12 plus 2 upon minus 15. So it can be written as like this. Okay. Now the next step, LCM of 12 and 15. 12 is what? 2 into 2 into 3, and 15 is what? 3 into 5. So LCM will be 2 into 2 into 3 into 5. That is 60. Now what? Write 60 over here. Now 12 into 5 will be 60. So that 5 into 1, it's 5, and a negative sign is there. Then further we have negative sign. 15 into 4 is 60. So that 4 into this 2, it's 8. Okay, so minus 5 minus 8 is minus 13, and this is by 60, right? So the procedure is very simple. You need to have some practice only. Okay, let's take 1 or 2 more problems. Now here it's negative, it's also negative, so precisely it's like this. Now take LCM of 19 and 57. So 19 is equal to 19, and 57 is equal to 19 into 3, right? So LCM will be 19 into 3, that's 57 only. Okay, now take this two. LCM is 57. 19 for how many times will be getting 57? That is 3. So this 3 into this 8 is 24, and put negative sign. Then 57 into 1 will be 57. So that 1 into this 4 will be 4 only, and do not forget this negative sign. So 24 plus 4 is 28 with negative sign by 57. Right? So the answer of this is minus 28 by 57. I'm sure you are getting it now. Now let's see this question. LCM of 8 and 36. Eight is 2 into 2 into 2. 36 is 2 into 2 into 3 into 3. Okay, so LCM will be 2 into 2 into 2 3 times, then 2 times 3, right? So it's 8 into 9, 72. Okay, now write 72 over here. 8, how many times will be getting 72? That is 9. So that 9 into this 13, that's 117 with negative sign. Then plus 36 into 2 will be 72. So that 2 into this 5 will be 10. Okay, so it's minus 107 by 72, right? So it's very simple, friends, and take some problems on your own, or you can print from the website, like good number of worksheets you can print. So take the print and then solve it on your own. Okay, match the answer because every worksheet is followed by the answer sheet, right? So I hope you are getting it now. Friends, I hope you might have enjoyed the session. In our next session, we'll be discussing some properties of addition of rational numbers, right? And even we'll be learning some more terminologies related to rational numbers, right? So let's meet in the next session once again. Bye-bye. Do revise this session. Yeah.